The National Electrical Code, or NEC, does not mandate the installation of a 110-volt outlet within 25 feet of a rooftop AC unit. Electrical codes such as the NEC are designed to ensure safety and standardize electrical installations. They provide guidelines for various aspects of electrical systems, including wiring, grounding, overcurrent protection, and equipment installation. These codes are regularly updated to reflect advancements in technology and address new safety concerns. Adherence to these codes is essential to prevent electrical hazards such as fires and shocks. The NEC is a comprehensive set of standards developed by the National Fire Protection Association, or NFPA, and is widely adopted throughout the United States. It is not a law itself, but it is often adopted by state and local jurisdictions as the basis for their electrical codes. The code covers a wide range of electrical installations from residential wiring to industrial power systems. It addresses topics such as conductor sizing, circuit breaker ratings, grounding requirements, and the installation of electrical equipment. The NEC is updated every 3 years to incorporate new technologies, address emerging safety concerns, and clarify existing requirements. The updates are developed through a consensus-based process involving experts from various fields, including electrical engineers, contractors, inspectors, and manufacturers. The code is organized into chapters, articles, and sections, each addressing a specific aspect of electrical installations. Chapter 1 covers general requirements such as definitions, wiring methods, and conductor identification. Chapters 2 through 7 cover specific types of electrical installations such as branch circuits, feeders, services, overcurrent protection, grounding, and wiring methods. Chapters 8 and 9 cover communication systems and tables respectively. The NEC provides detailed requirements for the installation of electrical equipment, such as transformers, generators, motors, and control equipment. These requirements are designed to ensure that the equipment is installed safely and operates reliably. The code also addresses the installation of electrical systems in hazardous locations, such as areas where flammable liquids or gases are present. In these areas, special precautions must be taken to prevent explosions and fires. The NEC specifies the types of equipment that are permitted in hazardous locations and the installation methods that must be followed. The NEC also includes requirements for energy efficiency. These requirements are designed to reduce energy consumption and lower utility bills. The code specifies minimum energy efficiency standards for various types of electrical equipment, such as lighting fixtures and motors. The NEC is a complex and comprehensive document that requires careful study and understanding. Electrical contractors, engineers, and inspectors must be familiar with the code to ensure that electrical installations are safe and compliant. The NEC is available in print and electronic formats. The NFPA also offers training courses and other resources to help people understand and apply the code. While the NEC does not specifically require a 110-volt outlet within 25 feet of a rooftop AC unit, other factors may influence the need for such an outlet. For example, local codes or regulations may have additional requirements. Additionally, the equipment manufacturer may recommend or require an outlet for servicing or maintenance purposes. It is always important to consult with local authorities and the equipment manufacturer to determine the specific requirements for a particular installation. Consider the practical aspects of maintaining the AC unit. Having a readily accessible outlet nearby can simplify servicing and repairs. Instead of running extension cords from distant locations, technicians can quickly plug in their tools and equipment. This can save time and reduce the risk of accidents. Think about the types of tools and equipment that might be used to service the AC unit. Many common tools, such as drills, saws, and testing equipment, require a 110-volt power source. If these tools are likely to be used, an outlet nearby would be beneficial. If the AC unit requires regular maintenance, such as filter changes or coil cleaning, an outlet nearby can make these tasks easier. Technicians can use power tools to speed up the process and improve the quality of their work. Consider the safety implications of not having an outlet nearby. Running long extension cords across the roof can create tripping hazards and increase the risk of electrical shock. An outlet nearby can eliminate these hazards and create a safer working environment. The NEC addresses the installation of outlets in various locations, including rooftops. While it does not mandate an outlet near every AC unit, it does provide guidelines for the safe installation of outlets in general. These guidelines cover topics such as GFCI protection, weatherproofing, and the proper use of conduit. When installing an outlet on a rooftop, it is important to follow these guidelines to ensure safety and compliance. GFCI, a ground fault circuit interrupter, protection is required for outlets in damp or wet locations. This type of protection can prevent electrical shock by quickly disconnecting the power if a ground fault is detected. Weatherproofing is essential to protect the outlet from the elements. This can be achieved by using a weatherproof enclosure and a weatherproof cover. The use of conduit is recommended to protect the wiring from physical damage. Conduit is a metal or plastic pipe that provides a protective enclosure for electrical wires. The NEC specifies the types of conduit that are permitted for various applications. When installing an outlet on a rooftop, it is important to consider the accessibility of the outlet. The outlet should be located in a place where it is easy to reach and use. It should also be protected from damage from weather or other hazards. If the outlet is located in a difficult-to-reach area, a dedicated circuit may be required. A dedicated circuit is a circuit that serves only one outlet. This can help to prevent overloading and ensure that the outlet has sufficient power. The NEC provides guidelines for the installation of dedicated circuits. The size of the wire used for a dedicated circuit depends on the amperage rating of the circuit. The NEC provides tables that specify the minimum wire size for various amperage ratings. The circuit breaker or fuse that protects the circuit should be rated to match the amperage rating of the wire. When installing an outlet on a rooftop, it is important to consider the overall design of the electrical system. The outlet should be integrated into the system in a way that is safe, reliable, and compliant with the NEC. This may require the involvement of a qualified electrical engineer or contractor. An electrical engineer can help to design the electrical system and ensure that it meets all applicable codes and standards. An electrical contractor can install the outlet and other electrical equipment in accordance with the design. When working with electricity, it is always important to take precautions to prevent electrical shock. Never work on electrical equipment while it is energized. Always disconnect the power before working on any electrical equipment. Use insulated tools and wear appropriate personal protective equipment. If you are not comfortable working with electricity, hire a qualified electrician. Working with electricity can be dangerous, and it is important to take the necessary precautions to prevent accidents. Before starting any electrical work, it is important to obtain the necessary permits. Permits are required for many types of electrical work, including the installation of new outlets. The permit process helps to ensure that the work is done safely and in accordance with applicable codes and standards. The local electrical inspector will review the permit application and inspect the work to ensure that it meets all requirements. The inspector may also provide guidance and advice on how to perform the work safely and effectively. Failure to obtain the necessary permits can result in fines and other penalties. It is also important to keep accurate records of all electrical work that is performed. These records should include the date of the work, the name of the person who performed the work, and a description of the work that was performed. These records can be helpful in the event of a problem or if future work is required. They can also be used to demonstrate compliance with applicable codes and standards. When selecting an outlet for a rooftop installation, it is important to choose one that is suitable for the environment. The outlet should be weatherproof and corrosion resistant. It should also be rated for the appropriate voltage and amperage. The outlet should be installed in a location where it is protected from physical damage. The outlet should also be accessible for servicing and maintenance. When installing an outlet, it is important to follow the manufacturer's instructions. The instructions will provide detailed information on how to install the outlet safely and correctly. The instructions will also provide information on the proper grounding and wiring of the outlet. Failure to follow the manufacturer's instructions can result in damage to the outlet or other electrical equipment. It can also create a safety hazard. After installing an outlet, it is important to test it to ensure that it is working properly. The outlet should be tested with a voltage tester to ensure that it is providing the correct voltage. The outlet should also be tested with a circuit tester to ensure that it is properly grounded. If the outlet is not working properly, it should be repaired or replaced. A qualified electrician should be consulted to diagnose and repair any electrical problems. The NEC addresses the use of arc fault circuit interrupters, or ASIs, in certain locations. ASIs are designed to protect against electrical fires caused by arcing faults. An arcing fault is a dangerous condition that can occur when electricity jumps between two conductors. ASIs are required in many locations, including bedrooms, living rooms, and dining rooms. The NEC provides detailed requirements for the installation of ASIs. When installing an outlet, it is important to consider the potential for electromagnetic interference, or EMI. EMI is a type of electrical noise that can interfere with the operation of electronic equipment. EMI can be caused by various sources, including power lines, radio transmitters, and electrical equipment. The NEC provides guidelines for minimizing EMI. These guidelines include the use of shielded cables, filters, and grounding techniques. When installing an outlet near sensitive electronic equipment, it is important to take steps to minimize EMI. When working with electrical wiring, it is important to use the correct type of wire. The NEC specifies the types of wire that are permitted for various applications. The wire should be sized appropriately for the amperage rating of the circuit. The wire should also be insulated to protect against electrical shock. When installing wiring in a conduit, it is important to use the correct size of conduit. The conduit should be large enough to accommodate the wires without crowding. The conduit should also be sealed to prevent moisture from entering. When making electrical connections, it is important to use the correct type of connectors. The connectors should be rated for the amperage rating of the circuit. The connectors should also be properly tightened to ensure a secure connection. Loose connections can cause overheating and electrical fires. When splicing wires, it is important to use the correct splicing techniques. The splicer should be made in a way that is mechanically strong and electrically sound. The splicer should also be insulated to protect against electrical shock. When installing electrical equipment, it is important to follow the manufacturer's instructions. The instructions will provide detailed information on how to install the equipment safely and correctly. The instructions will also provide information on the proper grounding and wiring of the equipment. The NEC is a living document that is constantly being updated to reflect changes in technology and safety practices. It is important to stay up to date on the latest version of the NEC. The NFBA offers training courses and other resources to help people understand and apply the NEC. The local electrical inspector can also provide guidance and advice on how to comply with the NEC. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. They can assess the specific requirements of your installation and ensure that it is safe and compliant with all applicable codes and standards. Remember, safety is always the top priority when working with electricity. Take the necessary precautions to protect yourself and others from electrical hazards. If you are unsure about anything, seek professional assistance.